Okay, somebody read. The peddler man is back again. This time he's trying to sell you an engine.
I'll take it.
You'll take it immediately?
Oh, never worth it.
Ooh.
No. I mean, he had it last time.
Well, he had it last time. So are you going to trust him the next year he shows up with this engine?
Do I have enough money for food?
No. This is it. You can just buy the engine.
No.
Okay, so can somebody read it, please?
All right. A peddler man comes around with this time with an Otto cycle and claims that it is 90% efficient. Will you buy it from him? Assume the following values are given. At point 1, pressure is P1 equals 1 atm and temperature is T1 equals 140 degrees Fahrenheit. At point 2, pressure P2 equals 15 atm. And at point 3, the temperature is T3 equals 3,940 degrees Fahrenheit.
Okay, so what are we given? Points 1, 2, 3, and 4. We are given for point 1, P1 as 1 atm and T1 as 140 degrees Fahrenheit. Yeah, neither of them will work. For point 2, they give you P2 as 15 atm. That won't work either. Then for point 3, they give you no pressure, but they give you a T3, which is 3940. And then for point 4, they give you nothing. Ooh. So that means you have to find T4. And you have to find T2. What is 1 atm? 101 times what? Okay, well, that's good. What is 15 atm? Yeah, there's a problem. T1 isn't given in Fahrenheit. We need it in what?
Kelvin.
Excellent. How do I convert Fahrenheit to Kelvin?
Convert to Celsius and then 1970.
Yes. So first you convert it to Celsius and then you have to convert it to Kelvin. And what you can do also, that should go on your note cards, by the way.
Fahrenheit to
Fahrenheit, Celsius, conversions to Kelvins, all of those, if you don't remember them, should go on your note cards. Usually I tend to think of it as this. X minus 32 times 5 by 9 plus 273 will give you the answer in Kelvin. Would you want to put 0.15? Okay. 0.15. Okay, someone tell me the answer for T1.
333.15.
333.15 Kelvin. Somebody tell me the answer for T3.
2,444.261.
That's a lot of Kelvin.
Yeah. Now, problem. We do not know these two. But I made you do something for ideal gases in homework and in class. Do you guys remember? That had gamma in them. So for T2, So then this one, I think is equation 4.57. P2 over P1 is P2 over P1, gamma minus 1 over gamma. What is gamma that's given? 1.4. What is P2 and what is P1? And what is T1? We're given stuff, right? Can we plug them in to find T2? Okay, somebody tell me the answer.
720.3.
Okay, so T2 is 700 what?
720.3.
720.3. Excellent. And now how do I find T4? So what is T4? So from step 3 to 4, we said it was adiabatic reversible expansion. And they give us, these are the same. So I can use equation 4.65, which will be T4 over T3 equals V3 over V4 gamma minus 1. And I also know that steps 1 to 2 is adiabatic reversible compression. Adiabatic reversible compression. So then I can write T1 over T2 equals V2 over V1 gamma minus 1. Now look at the picture. Is V1 the same as V4? Is V2 the same as V3? So may I write the left-hand side of these two equations to be equal? The ratios will be equal? V3 over V4, V2 over V1? From this picture? Will the ratios be the same?
Yes.
Good. That means, may I write from these two expressions, since the right-hand sides will be the same, may I write this as T4 over 3 equals T1 over T2? Bobbleheads? Yes, good. Do I know T1? Do I know T2? Do I know T3? Can I find T4? So T4 will be T1, T3 over T2. And the answer comes out to be, drum roll,
1,130.5.
1,130 Kelvin. Cool. Cool. Okay. Now, I have a table. I suggest you guys make this table. Oh, I should put my values in here so I don't lose them. What was it? 1130? 1130 Kelvin. And what was T2? 720 Kelvin. Okay, now go back to your picture. What is step 0.1 to 2? What is that called? Thank you. What do I know about adiabatic compressions? So will Q12 equal 0? Yes? What do I know about internal energies? Delta U will always be CV T2 minus T1. Do I have T2? Do I have T1? Do they give me CV? Done. And what will be work? We know from our first law, delta U equals Q plus W. So what will be my work? Equal to delta U. Whatever value of delta U you will find, you'll just plug it in here. Excellent. So this was step number 1, 2, 3. Now, what is step number 2? What was step 2? What was it called? Step 2 is what kind of a step? 2 to 3. Isochoric. So a constant volume step. What do I know about constant volume steps? Work is 0. So W 2 to 3 must be 0. How do I find delta U? From 2 to 3? CV T3 minus T1. Which means Q 1, 2 will be given as delta U 2, 3.
Why is it T1?
Oh, sorry, T2. You're right. This should be T2. My fault. Do we know T3? Do we know T2? It's literally plugging them in. Not doing that.
Q1 2 equals delta U 2.
In the heat column.
In the heat column.
Point
Oh,
two.
well, you guys can fix that. Come on. Okay, now what is step 3 to 4? Adiabatic expansion. What do we know about adiabatic expansions? Good. That means Q3, 4 must equal 0. What about delta U 3, 4? Or you could just use the same formula and then use that to find work, right? Work 3, 4 will be just equal U. What about the last one? Points 4 to 1.
Or
Again, isochoric, right? So I'm just going to call it constant V. What do I know about constant V steps? Work from 4 to 1 must equal 0. What about delta U? T1 minus T4? Yep. And what about Q 4, 1 this time, right? It'll just be delta U 4, 1. So then you can find net for everything. Your Q net, your U net, and your W net. And you will find that this number and this number are going to be exactly the same, but with one sign being plus and one sign being minus. And you will find this number to be 0. And that makes sense of why this number should be 0, because what did you do? You went from point 1 and you came back to point 1. How much work, total work did you do? So what is a change in internal energy? 0, right? Okay, now, last thing, should you buy it from him? Well, work net divided by Q in, I calculated to be about 54%. And he's claiming it's 90% efficient? Yeah, good luck.
Well, I wouldn't have money for food, and the temperature is like the melting point of steel. So
Yeah. Very high. Yes.
So Q in would be Q to the very.
No, actually, it'll be Q2 to 3 and Q4 to 1. Remember? So you add those two numbers together. And the same thing with W net. It will be 1 to 2 and then 3 to 4. So add those two numbers together. Woohoo! We're done.